All right, guys. So we are going to continue with our problem set. Okay. So Brayden, go ahead and come up here. Take your workbook, your learn book. Turn around. Okay. So yes. Oh, wait, I got it. I'm the teacher. I got it. It's okay. Sit on right there. That's your shot. Ethan, you're gonna sit up here. Yes. And then Christian, you will work with. You're gonna come up here with Julian and Aurora. Okay. So pull your chair up. Okay. So listen. Raise your hand if you're partner A. Raise your hand if you're partner A. You're A, raise your hand. Partner A. A, good. Okay, partner A, you are going to be doing C. C, you're being assigned C. Partner B, raise your hand. Partner B, raise your hand. You are being assigned D. Okay? Yes? All right. Next. Wait. Give me a second. I'm not done giving you my instructions. Okay. If once you're done, you're each gonna have 5 minutes to work on C and D, right? Then we're gonna stop once the timer's up. You're gonna stop. And then partner A will go first and you're gonna walk partner B how you did problem C, right? Then partner B, once that timer's up, once your timer's up, partner B, you're gonna walk partner A on how you did problem D, okay? Yes? Do we understand? Are there any questions about what I just said?
No.
Yes.
We only do the one we're assigned, right?
You're only doing the one you're assigned. Okay? Next. Okay? Once we move on from that, okay, I'm going to start calling on people to help guide me. Okay? Remember, how do we subtract fractions with mixed numbers? Using method 1. Method 1 is what? Creating first, we have to what? Create a what? We have to create what? An LCM. We have to find the LCM between the fractions. And then we create a what? Alexis. We create a rectangle fraction model. Then after that, what do we do? Using method 1, right? So what did we do in method 1? We rename, okay? We rename the fractions. That's kind of creating equivalent fractions, but we create an improper fraction first, right? Then you what? After you created, yes, what do? You make them equivalent. We've already done that. Then what? After you've made them equivalent, after you made an improper fraction, you what? If you're subtracting, you what? You solve, right? You solve. Exactly. So then you solve. If we're using method 2, which is what I want you to use this time, okay? I want you to use method 2. We subtract from the whole, right? And then what do we do with the rest? Yes. We add it to the end, right? We add it to the end, yes.
So we're doing method 2?
We're doing method 2, okay? I want you to do method 2. Yes, you have to show me that you know how to do the rectangle fraction model, okay? Just for this one, okay? All right, so partner A, right now both of you will be working on each of your individual problems. You have 5 minutes, go. Okay. No. I can tell them right now. No worries. Yeah, no worries. Okay, bye. Hey, Shab. What was last? Yes. Christian. I'm actually gonna have to look at everything. Okay. Make sure that I won't be sure. It's killing me. What are you supposed to do first? Okay. Did you draw your rectangle patches on? Draw it. How many rectangles do you need for this? Right there. Just sit right there. Sit right there. How many do you need? No, how many rectangles do you need for one of these? Oh. How many rectangles? Oh. About 3 more minutes. What did you find about Huh? Okay, so then we can go to the fraction page. What's the fraction part here? 8-1. There you go. So 8 8. So we're gonna go to the fraction here, right? So however you want, however you way it's gonna represent. Good idea. So what do you do next? So you said this is 8 8s, right? So this is 8 8s. So the 8 8s would be. Okay. So now do an expression. So you can do it for all of them. So write your expression. 8 8s. No. 3 8s plus what? 3 8s, right? What's gonna be the total fraction? Create a equivalent fraction. Equivalent fraction. What's the unit denomination? So what is this? So you have 8 8s, right? All right. Huh? Partner A. Partner A, raise your hand. Okay, I want you to walk partner B on how you got the problem, how you got your answer. Okay? Start with the first step you took. You have 3 minutes. Go. No, after you already discussed it. Okay, so how did you do it? What's the first thing you did? So what did you do to find the LCM? What did you do to find the LCM? Okay, but what did you do? What steps did you take to find the LCM? So you listed the multiples. Say, I listed the multiples, I think. Okay. Of what? Of 8 and what? 2. Okay. So you decided that. What was your LCM? So that I decided. Okay. And then what did you do next? Next, I the rectangle fraction model. Rectangle model and the parts of my whole. So you created what here? Well, what is that called? What did you do? What's the name for that? What did he do? Created what? Equivalent or reading. Yes. Okay, ready? So when you create an equivalent fraction, then what do you do next? Because you're not done, right? So what are you supposed to do next? Kylie. No, you're not. Using method 2. You're supposed to what, Eileen? No, you're subtracting, right? So what are you going to subtract? 4/8 from what? Okay. Is that right then? What does that give you? 4/8 minus what? Plus, and what do you do with this? Add it to what? What is that? 3/8 plus 4/8 is what? Now, you already walked in and so what do this. If you feel that she's done something wrong, say, I have to disagree with you. Okay, I disagree with you. You should. I think you need to come to system. Okay? You understand? Okay, go. Alright, partner B, raise your hand. Partner B, raise your hand. Okay, go ahead and walk partner A through what you just did. Equivalent fractions, so now what? We're doing method one.
Oh, cities.
What expression? Shouldn't it look like? Shouldn't it look like? This is your new one, right? Shouldn't it look like 2 tenths plus 4 tenths minus 5 tenths? Shouldn't it look that way? And then what do you do? Subtract from where? And what do you get when you subtract 2 tenths minus 5 tenths? And then what do you do with this here? Add it. Not plus it, add it. 5 plus 4 tenths. Okay? Alright, thank your partner for sharing. Okay. Now, let's go through this together. So we have 1 3/8 minus 1/2. Right? 1 3/8 minus 1/2. What do I do? First, let me ask this question. How many rectangles am I going to need to represent 1 3/8? Show me with your fingers. Show me with your fingers. How many rectangles do I need to represent 1 3/8?
Oh.
1 3/8. Not the whole expression, just 1 3/8. Not the whole expression, just 1 3/8. If you said 2, you are correct. For 1 3/8, I need 2 rectangles, right? How many parts are in my rectangle, Kevin? 8. Okay. How many rectangles do I need to represent 1/2?
The what?
What were you asking a different question?
You said we're
How many rectangles do I need to represent 1/2?
1.
Okay. And how many parts are in this whole?
1.
In 1/2?
Oh, 2.
Okay. How many should be, what is this? This represents this, right? We know this. This represents this. And this represents this, right? So how many should be shaded in here? Yes, Christian. All of it should be shaded in. What about for 3/8? How many should be shaded in? 3. 1, 2, and 3. Alright, what is the fraction representation of this? Show me. Show me on your whiteboard. What is the fraction representation of this? No, of just this one rectangle. Of just this one rectangle. The fraction. Of just this rectangle right here. If you said 8/8, give yourself a pat on the back. Good. Right? What about here? What's the fraction here? We know it's what?
1/2.
Right here.
Oh.
3/8. And here it's what?
1/2.
1/2. Okay? Now that we know this, what do we need to know next? What do we need to know next, Isaiah?
Oh wait, can you color that 1/2 real quick?
Oh yes, I'm sorry. I apologize. What do we need to know next? Yeah.
The LCD.
The LCM, what's gonna be my LCM?
8.
8. Okay, good. So 2 of my fractions already have a denominator of 8. So do I need to create equivalent fractions for these?
No.
No.
So what do I need? Which one do I need to create an equivalent fraction for, Danny?
1/2.
1/2. And what should be the equivalent fraction for that?
One should be 4/8.
4/8. So I'm gonna add more here. Right? And what is the equivalent fraction you said was what?
4/8.
4/8. Okay, good. 4/8. Okay. So using method 2, right? What should I subtract? What should I do first? What should I do first? Using method 2, what should I do, Ariana? What should I do?
We should. I didn't do that.
Okay. So what do you think now that you know we're doing method 2? Tell me, what should we do?
We should.
Should I add these 2 together first or should I subtract something else first?
I think we should subtract.
What should I subtract? What do you think? You wanna have a friend help you out? Okay,
Donna?
Donna, what do you think?
4/8 minus 8.
So yes, we're gonna subtract from the whole. Say it with me. We're gonna what?
Subtract from the whole.
Subtract from the whole. So 8/8 minus 4/8, right? And that gives us what?
4/8.
4/8. Okay, so then I still have, right? Because I brought this down and I brought this here, right? Because I covered this up. What do I do with this 3/8, Daniel? What do I do with it? Yes. What am I gonna do with this? What do I do with it? Now that I've subtracted 8/8 from 4/8, right? So I've done this. What do I do with this? I still have this. We what? We add the 3/8. Good. Good. Do we understand? What does that give us?
7/8.
7/8. Good. Okay. Okay, guys. You guys have to go to UA.